Well, welcome to another lecture. Today we're doing counters. We already did timers. Timers count units of time. Counters count events, rung transitions. When a rung goes from false to true, it increments or decrements depending on the instruction. The rung condition, true-false condition, has to go false again and true again to increment or decrement one more time. With other platforms that you've probably worked with, there is a counter data type. And that counter data type has a preset, an accumulate, and some control bits. And you can use a count up instruction to count that register up one, or you can use a count down to count it down one. Now, Micro 800 has count up, count down, and count up down. So if you're going to just count up and that's it, then use a count up. If you're going to set some preset value, like you want to empty out X number of components from a location, when you initiate it, you put in a preset of 10, and every time you take one out, it counts down, and when you hit 0, there's no more left. If you're loading up a layer in a carton, pick and place, you set your preset to 10, and every time you put one in there, it counts up one. A count up, count down allows you to go both directions. And typically, that's what we would use for occupancy on a conveyor. As a carton or an object goes onto a conveyor, we count up, and when it goes off the other end, we count down. So this is really not a big lab project. So let's just get right into it. Count up, count down, and count up, down. We had you add a rung of logic into lab project M12 so we could demonstrate the count up block type instruction. We drag down a true if on, and we could pick the variable here, but instead I like to type it in directly here. IN, and of course it comes up, first one 00, that's what we want. Now in the lab project you may not have realized right away that I was using the template, but when you look at the variables IN00, if that's what you did, you just did a Boolean IN00, that's fine. But you do have to attach that to an input if you want to use the simulator to operate this logic. Then we needed a count up instruction, so we went to the toolbox, and you could get it up here. We'll go over real quick here to timers and counters right there. So we could go up and get the count up instruction right here, but in the manual I showed you dragging in an instruction block and then typing in CTU, and it comes up with the count up and the count up down. So we select the count up. We left the default name of count up _1. Then we needed two output type instructions, and we wanted the indirect contact, and again we could get those up here. We could scroll back to bit, and we could get the direct coil and the indirect coil, or the reverse coil as they're calling it. So we'll just drag it down from there. So we have an indirect coil. I'm going to cancel and put in the tag or the variable the way that I like to do it, and then we branched around. Now notice when I'm going to do that again. Notice when I dropped in that branch around, it didn't go around the instruction. That's because I added it right there instead of right there. Do that again. If I drop it right here, it's going to drop it between this plus sign and this instruction. See that little dark mark there? If I put it over here, then it's going to go around the instruction. Just a little tip. Now we needed a direct coil. Now we can put some tags on these, and we use two different tags or variables. OU, I'll put 0, and then do the same thing again. We type in an O, and that's enough to bring up what we want, and there you go. The other thing that we did is that we had, for reset, we used IN01, and then for a, if you want to call it a preset variable, we had 5. And that constituted our rung of logic right there. Here's our rung of logic. We want to save this and download. Remember, our instructions in the manual were that you were to turn on input 0. If you have a live controller, then you would have flipped the switch to turn on input 0. With the simulator, it should behave the same way as a real controller. So before you downloaded, you made sure that input 0 was on and all others were off. We downloaded and the logic comes up, and as you would expect, input 0 is on. So the true if on instruction is true. That's reading input 00, IN00. Notice that the controlled variable or the count variable, the accumulate, whatever you want to call CV, is 1. Remember, the way that these instructions work is they increment based on false to true transitions of the rung. And then because the input is on the first scan, it sees a false to true. This is the one anomaly I don't care for about the counter instructions, is that if the rung is true, when you go online or when you download it, it increments 1. In the manual, we had you do something, but remember that the manual was written, at this point, it's either using the micro 820 or 850 or 870. But the point is, it was a live hot controller, not the simulator. So powering down a real controller is a no big deal. You just remove power and plug it back in. Trying to do that same thing and make it behave the same way with a simulator, we're actually going to have to stop the simulator. So I'm going to drag this up out of the way, bring the simulator over into view. You see that everything's running. So the only way that I can power down the simulator, you can't do it from here. This doesn't turn the power off, and neither does this. It just says it's powered on. If you click on that, it's not going to power it off. You have to stop it. When you stop it, of course, you lose the connection because there's nothing to connect to. This is basically putting the simulator in limbo, because remember, when we start the simulator again, it's going to come up exactly the way it was. So we'll start it again, we'll power it up, and then we'll make sure that input 0 is on. Okay, now we're going to connect, but you got to make sure input 0 is on, because when we shut it down, it lost input 0. Now that to me doesn't appear to be a 100% perfect simulation of a real controller, because if the field device connected input 0 was feeding voltage to that screw terminal, when this comes up and running, that would still be on. Now let's connect. So you go up to where it says disconnected and click there, or you can go over here and say connect. Either one will do. Notice I've got 3. This is not what I wanted, but let me tell you exactly what happened. I went up here and clicked. Remember I told you to click here, or you can go over and click here. I clicked those twice. So I actually told it to connect, then I told it to disconnect, then I told it to connect. But this is even better. Look at your count, 3. And I haven't toggled this. Let's go ahead and toggle this. Off and on. Toggles to 4. We got this to go to 3 without toggling that input one time. Now with a real controller, you're going to get the same thing. That's why this is in the manual, to demonstrate if you want to call it a weakness or an anomaly with the counter instruction. It was the same way in the older products as well. For that reason, I typically use add and subtract instead of count up and count down. In other words, I'll add 1 to a number and save it as itself. In other words, if I have a variable count, I'll go count plus 1 equals count. In other words, I add 1 to the count and save it in the count. So I'm incrementing. Every time that instruction is true, I increment it. The problem with add and subtract, the math instructions, is they don't have what you would call a built-in one-shot. This instruction, the count up and the count up down, they only increment once or decrement once for each false to true transition on the CU or the CD input. With an add or subtract, they execute every single program scan. So if you put in an add instruction and you turned on the input to it so it was true and it would execute, and you were adding 1 to a number, then saving it, it would increment 1 every single program scan. What you end up with is a scan counter. If you want to count scans, just use an add instruction, unconditional. Adding 1 to a variable and saving it is the same name. In other words, you're just incrementing the variable by 1. Same thing with subtract, if you want to subtract scans. So that's what we were demonstrating in this part of the lab. There was a question in the manual, did the counter increment again even though you did not operate input 0? Yes. Why? Because the processor went from not running to running, or it went from powered off to running. So the way it executes the logic on the first scan is it sees input 0 is on. It doesn't know that it was, see, the counter instruction is what doesn't know what's going on. So the counter instruction doesn't know that input 0 was on the last scan, because when you stop the controller, you're stopping the scan. So the count up instruction no longer has, if you want to say that, intrinsic knowledge that it's already gone through a false to true transition. As well, we had a question, and this was based on the CV being 5. So we have to toggle input 0 one more time. Now the CV equals the PV. So if you want to call this the control variable and the process variable, I'm good with that. I call this the preset and the accumulate. This is the value that's accumulated to. Once these are equal, then Q has a true out. This being a reverse coil turns off output 0, and this being a direct coil turns on output 1. So the question was, compare the state of the two outputs with this screen. Did they change states? Yes. Why? Because the PV equaled the CV. What can you say about the relationship between PV, CV, and Q? All that we're looking for here is that you understand that when PV is less than CV, then Q is false out. When PV is equal to or greater than CV, then Q is true out. Toggle input 0 on off once. Now we're at 5, so if we toggle input 1, that's the reset. Notice that the CV goes to 0. Did the CV reset to 0? Yes, it did. Toggle input 0 on off until the CV is equal to the process variable. Observe and a toggle once more. So let's bump it up to 5. Okay, I paused there at 5. I'm going to go one more time. Now notice that the CV did not continue to increment. This is a departure from RS Logic's both 5000, 500, MicroStarter, etc. Now, if you have no knowledge of other Allen Bradley products like the 5000, 500s, and MicroLogics, this doesn't mean anything to you. But with those products, the counter continued to count up. But the only thing that changed was the accumulate. I suppose the thinking here is that if you have a preset of 5, why would you want to count past that? In other words, if that was your goal when you reach PV equals CV to turn on Q or true out from Q to do something, well, what else is there to do? But just be aware, if you also work with the other products, that the count up continues to increment. This one does not. The question was, once CV equals PV, does the counter continue to increment? No. Save, disconnect, and go offline to make edits. Save, disconnect. We saved, went offline, and added another rung using the countdown instruction. And again, you can get these instructions from up here in the instruction menu, or you can go to Toolbox and drag down a function block type instruction and then pick the type that you want. Notice that we are using all unique memory locations, and we're using the same preset of 5. Save and download. Now here's something else that I'm not real excited about, and that is, and this may look like it's okay. If you look at the controlled variable or the count variable, the accumulate, they're both 0. And that seems okay because we really haven't done anything yet. But let's try toggling input 2 just for grins. It did not count down from 0. Now the instructions in the manual had you look at these two outputs and these two outputs and then reset both of these with input 1. So we'll do input 1 first. And you notice no change up here, right? No change in anything. Now do input 5 and watch here and here. Watch the CV and the outputs. We reset. Now here's another deviation from RS Logic counter types. With a count down instruction in RS Logics, if the CV was 0, if the accumulate value was 0, and you entered input 2, it would go to -1. It would count down. Notice that this came up with 0 for CV, and it didn't do anything when you hit countdown. But when you hit reset, it resets it to 5. And now you can count down from 5. That is a major departure from RS Logic and something you really need to be aware of if you're going to use these instructions. The next thing that we had you do, and by the way, I'll just go ahead and click on 2 here so you can see it counted down, it decremented from 5 to 4. So I'm going to reset it again, input 5. Okay, and it bumps it back to 5. Now, I told you to disconnect, save, disconnect, and then I had you change the preset variable values to 0 and then download. So I'm going to here, 0, save and download. We saved and download. Notice that in both cases, the preset variable equals the count variable. Q is true out, rung true out. And you notice that that turns on output 1, turns off output 0, turns on 3, turns off 2. Try toggling the count up switch and the count down switch. Does anything change? That means let's try input 0 first. See, it went true. Then back, nothing changes. Now let's try 2. Run goes true. The reason that we're doing this is so you have in your mind the behavior of these instructions if your PV is 0, if your process variable is 0. And the reason that that's important is because quite often when people use these instructions, they forget to put in a PV. It starts at 0, which means it's true out instantly. First scan, true out. Now, that doesn't mean that this will execute. This is technically false. See, this is false right here. This is true. So when I toggle on input 0, now it actually executes, but nothing's going to change. What's interesting here is that both rungs are false, but because PV equals CV, Q is true, and it does the true execution for these 2 instructions. Same thing down here. This instruction has a true out. So the answer in the manual was try toggling the count up, count down switch. Does anything change? No, it does not. Okay, so save this. You might as well go ahead and reset it with 1 and 5. I don't know if that's going to make any difference. That way we're leaving on a clean note. So we're going to save and disconnect. Here's our new rung of logic. Let's save and download. Downloaded in the run mode. In the manual, it asks you to identify the PV and the CV. So if you look, the PV is 5 and the CV is 0. Output 0 is on, off, it's off. Output 1 is on or off. Now it says output 1 is true, which means that it's on. So the countdown is done. It's counted down to 0. I know that doesn't make a whole lot of sense if you are accustomed to the counter instructions in other PLCs, not just Allen Bradley, but other PLCs. So let's reset the instruction. That would be input 2. And let's try counting down, which would be input 1. See, nothing happens. Input 1 went true, then false. Now let's try input 0. Went true, then false. We have a count of 1. Let's do that again. Okay, notice that output 1 is now false and output 0 because the CV is neither 0 nor 5. So 3, 4, now watch output 0, 5. So output 1 is false, output 0 is on. If we reset, which would be input 2, now we're back to 0. So we're reset to 0. We can't count down unless we're above 0, but we can count up. So we'll count up, get 2 counts, and we can count down 2 counts. 1, 2. Understanding the behavior of this instruction is the most important thing. We did not use the load input, but what would happen if you put a true in here, then it would set the CV equal to the PV. That way you could start counting down right away. So we have count up and count down, true rising edge detected, count up, true rising edge detected, count down, count up and count down. Reset, reset dominant command to CV equals 0 when reset is true. The load command, true, set CV equal to PV. PV, they're calling it the programmed value. I like preset, but they're calling it program value. QU is overflow, and that's true when CV is greater than or equal to PV, which means when you count up to 5 in this case. And we'll go ahead and do that. That would be input 0, 3, 4, 5. Okay, if I try one more time, it doesn't count up any higher. In the manual, it says true when CV is greater than or equal to PV. That is true, but CV would have to be set to greater than 5 somewhere else. And then QD, which is really right above it, is, they call that underflow. So QU, they're calling that overflow. I'm not sure about that terminology, but all that matters is that QU is true when the CV is equal to PV, greater than or equal to the PV. QD is true when CV is less than or equal to 0. And I don't see any way in this rung to make it less than 0. And then CV is the counter result. They call it counter result. I prefer to call PV the preset variable and CV the count variable or accumulate variable. So we had to increment CV to 1. We'll do that. We'll reset with 2, and then we'll count up to 1. And the question is PV equals 5, CV equals 1, output 0 is off, and output 1 is off. They're both off. The only time output 0 is on is if CV equals PV. And the only time that right here, output 0 is on if the PV and the CV are equal. Output 1 is on if the count is 0. And we can show you right here. Reset is 2. See, that went from false to true. Increment CV to 5. Let's just for grin see if I can type in a 5 there. Didn't like that. So we're going to bump it up to 5. PV is 5, CV is 5, output 0 is on, and output 1 is off. We'll reset. Now if you look down here on your simulator, we've been saying output 1 is on because that says true, but if you look over here at your simulator, you can see output 1 is on. So the terminology I find grammatically interesting. I'll just put it that way. But this software is getting better every day. You have demonstrated the range of the use of the count up, count down function block, except for selecting EN and ENO box and the load variable, which we will not discuss in this project. Learn the simplest uses and save the convolutions for another day. Sufficient to the day is the evil thereof. In your own words, describe the relationship of QU, QD bits, and the CV value. We've done that sufficiently. Count up, count down, and count up, down. Not a terribly exciting lab project, but don't worry, we're going to use the counter instruction. And that's the whole goal here, is we introduce you to an instruction, just the basic principles, how it behaves, comparisons. Then we put it in an application so you can see some way that you might use it. And I'm sure you'll get lots of ideas on your own as we go forward. So let's tidy up this lab project, and I'll see you for the next one.